was found in Uzbekistan in Central Asia. An analysis revealed it was from the skull of a new species of Tyrannosaur. It's called Timurlengia and measured 3 meters long. At a glance, it doesn't seem too different from its smaller ancestors. But internally, it's dramatically different.
We're able to look into its brain, into the ear using CAT scans, and we can see it had a big brain, very intelligent animal. We can see it had an ear that was really sophisticated, really good at hearing a wide range of sounds.
Brusati and his colleagues took scans of the cranium. Inside the inner ear is the cochlear duct, which is responsible for picking up faint sounds. They found that in Timurlengia, it had significantly evolved.
So what this is telling us is that these small tyrannosaurs were evolving bigger brains, greater intelligence. Better senses, when they were living in the shadows, when they were trying to survive in a world. World dominated by the allosaurs and other big predators.
Early small tyrannosaurs developed a key sense of hearing that allowed them to quickly sense enemies and escape, helping them to survive. But fleeing wouldn't have been enough to challenge and overtake Siach's dominant position. There's more to the mystery of how descendants of these diminutive siblings would have gone on to rule the dinosaur world. For many years, the evolutionary path from Guanlong to the giant T-Rex contained puzzling holes.
So, we know a lot about the very earliest tyrannosaurs now. We know they were small. We know a lot about the latest tyrannosaurs. We know they were huge. But in the middle, there's a gap in the fossil record, a dark period of tyrannosaur history where we know nothing. No fossils.
The Tyrannosaur's 100 million year evolutionary history contains an intriguing hole. It was during this time that the spectacular advances that led to T-Rex occurred. Mark Lowen has been researching this mystery. He's focused in on an ancient landmass on the North American continent called Laramidia.
The real changing point of Tyrannosaur evolution was the isolation and evolution that happened on Laramidia. Isolated populations of dinosaurs could evolve in isolation from other dinosaurs.
Around 90 million years ago, global warming caused sea levels to rise. This led to monumental flooding on the North American continent, causing it to become divided. The dinosaurs lived in the western part of the continent. Much of the land was covered with steep mountain ranges. Rising waters drove the dinosaurs to narrow strips of level land, where they became isolated. In these densely populated areas, meat eaters would have a significantly greater chance of finding prey. Lowen believes this is precisely what sped up the dinosaurs' evolution.
This crucible of evolution that is Laramidia, the small populations were able to undergo dramatic change and rapid evolution.
Revolutionary advances took place in many different creatures. Ankylosaurs evolved thick, bumpy skin like protective armor. Members of the Ornithomimos family developed the ability to run 60 kilometers per hour to escape predators. Similarly pronounced changes occurred among the Triceratops ancestors, hunted by Tyrannosaurs. They adapted for survival by becoming massively large. This gave them the power to repel attacks. From early ancestors weighing only 100 kilograms, they developed into creatures weighing more than 6 tons. But many uncertainties still remain about T-Rex's predecessors. In 2013, Lowen discovered a fossil that answered some questions. It's from a previously unknown species of Tyrannosaur called Lythronax. The fossil was buried in soil deposited 80 million years ago, during the evolutionary gap period.
The name we chose, Lythronax, means Gore king in ancient Greek. And we chose this name because Lythronax really was the top predator in its ecosystem.
The fossil indicates that Lythronax measured about 8 meters in length. That represents a remarkable jump in size from Guanlong, its weak ancestor. This new Tyrannosaur was large enough to battle with the massive Triceratops. Conditions were ripe for different species to influence one another's evolution. This phenomenon is known as co-evolution.
So tyrannosaurs were exploiting these prey species and also undergoing rapid evolution themselves. So it's really an arms race between the predators and the prey species, and all of these animals are evolving to have larger body size, both to defend themselves from predators and for the predators to be able to attack the herbivores.
Jimmy's gotten used to his whole room smelling like sweaty odors. Yep, he's gone nose blind. He thinks it smells fine, but his mom smells this. Luckily for all your hard-to-wash fabrics, there's Febreze Fabric Refresher. Febreze doesn't just mask, it eliminates odors you've gone nose blind to. And try Febreze Unstoppables for fabric. With up to twice the fresh scent power, you'll want to try it again, and maybe just one more time. Indulge in irresistible freshness. Febreze Unstoppables. Breathe happy.
Researchers believe that one factor supporting the Tyrannosaur's extraordinary growth was a jump in their hunting skills. Their heads, relatively delicate up to then, widened by about 3 times. That made astonishing improvements in eyesight possible.
One of the things that's unique about Lythronax is the fact that it has forward-facing eyes. Forward-facing eyes occur in modern animals that are predators. And that ability to have forward-facing eyes allows you to have overlapping field of vision and perceive depth. So depth perception clearly was possible in this dinosaur, and it's something we associate with hunting.
Depth perception makes it possible for a hunter to accurately grasp the distance to its prey. That would have allowed tyrannosaurs to catch prey more easily and turned them into much more successful hunters. They would have gotten plenty of nutrition, enabling massive growth. These changes culminated in the mightiest dinosaur of all, T-Rex.
By about 80 million years ago, a whole new world of dinosaurs had dawned. And this was a world that was dominated by the tyrannosaurs. They were the biggest predators and they ruled at the top of the food chain. And these were the tyrannosaurs that we're all familiar with, the ones like T-Rex. The ones that grew so fast that they put on 5 pounds of weight every day during their teenage years. And they were utterly in control. They were the kings of the late Cretaceous.
Overwhelming size wasn't the only result of the Tyrannosaur's continuous evolution. Lawrence Whitmer is a paleontologist who has studied the brains of T-Rex. He's used CT scans of fossils to analyze their brain structure. The scans point to new developments in sensory faculties.
One thing we saw when we started to reconstruct the brain of T-Rex is that the olfactory bulbs of the brain, the part of the brain that's involved in processing odors or smells, were really quite enlarged. What that told us is that the sense of smell was very important for T-Rex. It was potentially important for locating its prey.
Signals from the sensory organs were sent to and analyzed by the cerebrum. An index measuring intelligence based on brain to body size suggests T-Rex was more advanced relative to other dinosaurs.
The cerebrum, which in mammals like us is the seat of intelligence and planning and problem solving. The cerebrum in Tyrannosaurus was actually fairly expanded. We look at their brain and wonder whether that enlarged cerebrum may have actually had the capacity to be involved in sort of a coordinated group hunting effort, such that maybe some animals would actually drive the prey towards other animals, other tyrannosaurs that were laying in wait.
There he is, T-Rex. He's not only smarter, but also has a superior sense of smell. Even in the dark of night, he's able to locate his prey. Aiding his ability to track game is his keen eyesight. The Triceratops tries desperately to get away. But there's another T-Rex waiting in an ambush. Feasting on kills fueled growth. The Tyrannosaurs now measured 13 meters. Their bones grew harder and stronger, and their bodies were covered in muscles like steel. Some experts have questioned whether creatures this big had the speed needed to run down prey. The conventional belief was that T-Rex ran at a speed of 18 kilometers per hour. That would make it slower than a human. Tyrannosaurs were thought of as slow and clumsy. Paleontologist Bill Sellers challenged that view.
So it's very hard when all you've got is bones to try and work out how fast an animal would run. So what we were trying to do was to come up with evidence from living animals that we could use to work out how fast fossil animals would move.
Sellers and his colleagues looked for present-day animals that would approximate the movements of a tyrannosaur. They zeroed in on the ostrich.
And these ostriches are as close as we can get in terms of a modern animal that's a bit like a T-Rex. So they've got 2 legs, they've got very large bodies, and they're high-speed runners. A lot of the basic anatomy is exactly the same, so they do make a very good model.
Using the ostrich's movement as a reference, Sellers made a computer simulation of how a T-Rex might have run. The model showed which muscles a T-Rex would have used when running. Sellers took particular notice of the muscles connecting the thighs and the tail. Previously, experts thought these muscles were merely for tail movement, but it became clear that they also played a key role in helping the T-Rex to run fast.
And what it does is it pulls the thigh bone backwards. And so obviously this is the main powerhouse. Even though it's a very heavy animal, it can obviously generate the force that it needs to go at a good speed.
With this model, the average T-Rex's top speed increases to 30 kilometers per hour, and the strongest could run as fast as 50. The descendants of the primitive Tyrannosaur siblings have acquired speed, size, and intelligence. But there's more. Carl Bates is an expert on the bite force of dinosaurs.
with an enormous bite force and large neck muscles, it probably clamped onto its prey and pulled away at the flesh. There have been quite a few fossils found of plant-eating dinosaurs with T-Rex bite marks in them, where the bite marks go very deep into the bones.
A huge jaw powered this deadly bite. Bates has studied the structure of T-Rex's skull. He recreated the muscles that connected the upper and lower jaws. Then he used a computer simulation to quantify the strength of its bite. Bite force is measured in newtons. The lion, known as the king of the savannah, has a bite force of 4,000 newtons. The bite force of alligators, fearsome killers near water, is around 6,000 newtons. Compare this to the dinosaurs. The Allosaurus is considered to have been the strongest dinosaur before T-Rex. Its bite force was about 9,000 newtons. According to Bates, the T-Rex had a bite force of some 60,000 newtons. That's 7 times greater than the Allosaurus.
60,000 newtons is a huge amount of force, so we're convinced that T-Rex had a very large bite in absolute terms and was probably one of the fiercest biters of all time.
When a T-Rex bit into its prey, it exerted 6 tons of force. That's equivalent to the weight of an African elephant. In theory, such heavy loads could cause the jawbones to break. But something protected T-Rex from this.
That the skull was very important for capturing prey and consuming prey, and we were just interested in how this huge structure performed mechanically.
A T-Rex skull is made up of more than 40 different parts. Here and there are gaps measuring just a few millimeters. These gaps released force when the T-Rex bit and helped to soften the shock.
T-Rex has this reputation of being such a deadly, fearsome creature, so we're pretty convinced that T-Rex was one of the most ferocious biters of all time and worthy of the title King of the Dinosaurs.
A creature with both extraordinary physical capabilities and sophisticated intelligence. After 100 million years, T-Rex had reached the pinnacle of its evolution. A pair of T-Rex siblings. Even if they were to meet up with Siach, former ruler of the dinosaurs, they would have no reason to flee. They are no longer the small, weak Tyrannosaurs of old.
Jobs are being lost, but they're also being found. Even now, 500,000 new jobs from 50,000 companies are added every week on Indeed. If there's a job out there, you'll find it here.
The siblings set off on a new journey in search of more prey. They are heading back to the Eurasian continent. Along Along the way, they passed through areas inhabited by many relatives from the Tyrannosaur family.
T-Rex was the king of the late Cretaceous, no doubt about that. But not all tyrannosaurs that lived at that time were big, top-of-the-food chain predators like T-Rex. Some of them actually were quite a bit smaller. So even when T-Rex was ruling the world, there were other close cousins of T-Rex that were doing other things, filling other roles in the ecosystem, and doing a very good job at it.
2014. In northern Alaska, researchers found a new species of Tyrannosaur. They called it Nanuqsaurus, after the Inuit word for polar bear. At 6 meters, it wasn't even half the size of T-Rex. Experts attribute its small size to a lack of game. The same year, in Jiangxi province in southern China, a team dug up an unusual fossil. The most noticeable feature is its long, thin nose. It's been nicknamed Pinocchio Rex, in reference to the beloved character. Outwardly, it looks nothing like T-Rex, but a bone analysis confirmed it as a new Tyrannosaur species. Then, in July 2015, scientists made a discovery in Japan. Up until then, no one thought large tyrannosaurs had lived there. The team found fossils of 2 large teeth, each measuring 8 centimeters. Their size suggests they came from an animal 10 meters long. Finds like these illustrate the distinctive evolutionary paths taken by tyrannosaurs all over the world. So far, experts have identified 28 individual species. At one point, T-Rex truly dominated the dinosaur world. But in the end, it would meet a cruel fate. Evidence of this emerged in 2015. Scientists were excavating in Alberta province in western Canada. They found this fossil, a cousin of T-Rex called Daspletosaurus. Here and there, researchers spotted telltale signs of battle. A wound deep enough to pierce the bone. On the back of the skull, a part had been bitten off. Scientists wondered what kind of creature could have inflicted such wounds on the mighty Tyrannosaur. Paleontologist David Hone points to an unlikely suspect.
So you immediately have only one credible candidate for these kinds of injuries and these kinds of bites, and that's another large-bodied tyrannosaur.
Hone says the shape and size of the bite marks indicate a fight between 2 members of the Tyrannosaur family.
So they're going to hunt at the same time of day in the same place and have similar territories, and they're going to come into these conflicts. But I'm sure every so often there were fights to the death, and certainly we actually see evidence of cannibalism among tyrannosaurs. They do kill each other.
In turf battles, even siblings could become rivals. And if one refused to back down, T-Rex ancestors set out on a grand journey in search of new lands. On the North American continent, they confronted countless threats. But they managed to thrive. Their descendants continued to evolve, eventually becoming the undisputed rulers of the dinosaurs. But once at the top, these powerful killers turned their awesome power on one another. "66 million years ago, the reign of the dinosaurs came to a sudden end. Experts believe the reason was a gigantic asteroid that smashed into Earth. Resulting climate change wiped out the dinosaurs, including Tyrannosaurus. But was that really the end of the dinosaurs? Stephen Brussatti's research provides evidence that it wasn't. Certain creatures alive today are descended from a branch of the Tyrannosaur family. Birds. Once the dinosaurs died out, birds underwent a spectacular evolution. New species appeared, and they became the rulers of the skies. They were able to do this because of strengths they inherited from their Tyrannosaur ancestors.
We always talk about dinosaurs going extinct 66 million years ago when the asteroid hit, but really not all dinosaurs went extinct. Most of them did, but one type of dinosaur survived, and those are the birds. So birds evolved from dinosaurs, and they're actually a type of dinosaur, and they live on today. There's over 10,000 species of birds. There's birds flying around here. And so these birds are living dinosaurs, and so birds today carry on the genes of T-Rex.
Creatures unlike any seen before or since. The free spirit of T-Rex lives on.